Hello and welcome. Today we're diving into a really powerful tool called linear programming. You can think of it like a mathematical GPS for business. It's a way to find the most profitable route when you've got limited resources and you can't just have everything you want.
And that's really the fundamental challenge, isn't it? Every single company has a finite amount of time, money, materials, and people. So the multi-million-dollar question is always this: how do you make the absolute most of what you've got?
To really get a handle on this, let's walk through a classic business puzzle together. We're going to step into the shoes of a manager at a chocolate factory. And our job, figure out the perfect production mix to make the most profit possible.
All right, so here's our situation. We make two things: dark chocolate, which earns us 6 pesos of profit per bar, and light chocolate, which earns us 5. Now, each one uses a different amount of our two main ingredients, milk and choco. And here's the catch: our supply of both is limited. So our job is to find that perfect production mix, that sweet spot, that's going to maximize our total profit.
Now, this kind of problem, trying to get the best outcome with limited inputs, it's not unique to our little factory. This is a classic optimization problem. And luckily for us, there's a powerful framework designed specifically to solve these kinds of puzzles. So what is optimization, formally? Well, it's the process of finding the absolute best solution from all the available options, while having to work within a set of rules or limitations. Whether you're trying to maximize your profit or maybe minimize your costs, it's all about finding that single best outcome. But to put it a lot more simply, optimization is really just about making the best possible use of something. If you optimize your study time, you're figuring out how to get the highest grade possible with the few hours you have. In business, we're doing the exact same thing, just with things like budgets and raw materials. The specific tool we're going to use to solve our chocolate factory puzzle is called linear programming. It's a mathematical method that's just perfect for situations like ours, where all the relationships between our products, our resources, and our profits can be drawn as straight lines. So, to use linear programming, we first need to translate our business problem into a mathematical model. Now, that sounds complicated, I know, but it really just breaks down into 3 core parts. First up, we have the decision variables. These are simply the choices we get to make. In our case, the big decision is how many dark chocolate bars should we make and how many light ones. Let's just call these X and Y for short. Second, we've got the objective function. This is just our goal, but written as a formula. We want to maximize profit, right? Well, since we make 6 pesos for every dark bar, that's X, and 5 pesos for every light bar, that's Y, our objective is to make the final value of Z in this equation, Z equals 6X plus 5Y, as big as it can possibly be. And finally, the constraints. Think of these as the rules of the game, the real-world limits we have to follow. We only have 5 million units of milk and 12 million units of choco. These 2 inequalities you see here are just the mathematical way of writing down those limits. Any solution we come up with has to satisfy these conditions. It's not a suggestion. Okay, so now that we've turned our problem into math, we can do something really, really cool. Because we only have 2 things to decide on, X and Y, we can actually plot every single possible solution on a simple graph. So let's start with our axes. The horizontal one, the X-axis, that's going to represent the number of dark chocolate bars we produce, in millions. And the vertical Y-axis will be the number of light chocolate bars, also in millions. Simple enough? Okay, let's plot our first constraint, milk. The rule was X plus Y has to be less than or equal to 5. To graph it, we just find the extremes. So, if we produce 0 light chocolate, we could make a maximum of 5 million dark, right? That's our first point. And if we make 0 dark chocolate, we could make 5 million light. That's our second point. The line connecting those 2 points represents our milk limit. Any production plan has to be underneath that line. Now we do the exact same thing for our choco constraint. That one was 3x plus 2y is less than or equal to 12. So if we only made dark chocolate, we could produce 4 million bars, and if we only made light chocolate, we could produce 6 million. So now imagine a second line on our graph, this one connecting the 4 on the x-axis to the 6 on the y-axis. Our final answer has to fall underneath this line too. So when we put both of those areas on top of each other, the one for milk and the one for choco, the part where they overlap is what really matters. This shaded area is called the feasible region. And here's the key. Every single point inside this shape represents a production plan that is actually possible given all of our limitations. We've literally just mapped out every valid option we have. So we have this whole region, which means there are technically infinite possible solutions. So how in the world do we find the single best one,
the one that gives us the most profit.
Well, here's the magic trick. A fundamental rule of linear programming says that the absolute best solution, the maximum profit, will always be found at one of the vertices or corners of that feasible region. We don't have to check all the infinite points inside. We just have to check the handful of corners.
Now it's just a matter of testing those key corners. We can pretty much ignore the ones on the axes, since they don't use all our resources. So let's just plug the coordinates of the other vertices into our profit formula, z equals 6x plus 5y, and see what we get. Okay, so a mix of 1 million dark and 4 million light gives us 26 million, not bad. 3 million dark and 1 million light gives 23 million. But look at that middle one. A production mix of 2 million dark and 3 million lights gives us a total profit of 27 million pesos. That is the highest value out of all the corners. We found it. That's our maximum possible profit.
So there it is, the single best answer to our puzzle. To maximize our profit, given our resource constraints, the factory needs to produce exactly 2 million dark chocolate bars and 3 million light chocolate bars. Any other combination, and we'd be leaving money on the table.
And while our chocolate factory was a fun little example, this exact technique is an absolute powerhouse in the real business world. As future accountants and financial managers, you're going to use these principles to solve huge problems. Things like figuring out the best portfolio mix for an investor, allocating marketing budgets, scheduling production runs, and even streamlining entire supply chains.
And this all comes back to a universal truth in business. Resources are always limited. Time is always limited. The core job of management is to make the absolute most of them, and optimization gives us a structured, mathematical way to do exactly that. You know, this is so much more than a math exercise. It's a strategic way of thinking that you can apply to your entire career. Every budget you manage, every project you run is going to have constraints. So the real question is, when you're faced with those limits, what will you choose to optimize?